Hello everyone and welcome to e-sipnayan, your math guide through senior high school. So for today's video, we are going to discuss tests of hypothesis concerning population proportion. So don't forget to hit the like and subscribe button to our channel e-sipnayan. So the objective for today's video is to be able to test a hypothesis concerning population proportion using the 4 steps in hypothesis testing. So let's start with the definition of population proportion. So population proportion refers to a fraction of the population that falls under a certain characteristic. So for example, 60% of the students in a certain level are male. So this particular numerical descriptor is what we call population proportion. So how do we test a hypothesis concerning population proportion? So we follow the 4 steps in hypothesis testing. So first, we state the null and alternative hypothesis. Then, we set the standards that describes whether the claim is true or not. This is where we determine the boundary between the acceptance region and the rejection region using the level of significance and the type of test to be used. For this lesson, we will be using normal approximation through the central limit theorem. To use the normal approximation, the sample size must be large. Hence, we will be using the z-distribution to determine the critical values. After determining the critical values, the next step is to compute for the test statistic. So the test statistic will be computed using this formula. So we have z equals x minus n times p sub o all over the square root of n times p sub o times q sub o, where x is the number of success in the sample. So x represents the number of elements in the sample that falls under a certain characteristic. N, of course, is the sample size. P sub O is the percent success in the null hypothesis. So P sub O represents the assumed percentage of the population that falls under a certain characteristic, while Q sub O represents the percent fail in the null hypothesis, or the assumed percentage of the population that does not fall under that specific characteristic. So once you have computed for the test statistic, then we can make the decision to either accept or reject the null hypothesis. Now let's try this example. A manufacturer of shampoo claims that 40% of the females in a certain neighborhood prefers brand S. To test this claim, a random sample of 50 females are selected and asked what brand they prefer. So if 16 of the 50 females prefer brand S, can we conclude that the manufacturer's claim is true at 5% level of significance? So to test the claim of the manufacturer, we follow the 4 steps in hypothesis testing, starting with step 1, where we identify our null and alternative hypothesis. So for this particular scenario, our null hypothesis would be that 40% of the population of females prefer brand S. In symbols, we write this as P equals to 40%. While in the alternative hypothesis, we can say that the proportion of the population that prefers brand S is not 40%, since we are only proving if the manufacturer's claim is true or not. Hence, we can write this in symbols as P not equal to 40%. After we have stated our null and alternative hypothesis, we move on to step 2. In step 2, we're going to set the standards that determines or that describes whether the claim is true or not. So, we identify first our level of significance and the type of test that we're going to use. So, since we're simply determining whether the claim is true or not, we use a two-tailed test or a non-directional test at 5% level of significance. So, using our standard normal probabilities table, we can see that our critical z-scores lies at positive negative 1.96. In our normal curve, so the rejection region is of course our shaded region in this curve, so it lies at both left and right side of the normal curve. So once we have identified our critical values, we move on to step 3. In step 3, we're going to compute for the test statistic using the formula that I have presented earlier. So to be able to use the formula, of course, we have to identify the variables or the values to be substituted to the formula, starting with the variable x. So again, variable x represents the number of elements in the sample that falls under a certain criteria. Hence, since in our problem it says that 16 out of the 50 females prefer brand S, x would be equal to 16. Next, we have P sub O. So this represents the assumed population proportion that falls under the certain criteria. So we have 40%, so 0.4. While Q sub O represents the assumed population proportion that does not fall under that criteria. So if 40% prefers brand S, then 60% does not prefer brand S. Hence, 0.60 is our Q sub O. Okay, and our last value would be the sample size, which is 50. So plugging that into our formula, we have Z is equal to 16 minus 50 times 0.4 all over 50 times 0.4 times 6.60. So when you use the calculators to compute for the computed value of Z, we have Z equals negative 1.15. So once we have computed our computed test statistic, then we move to step 4. So since the computed value falls under the acceptance region, the decision is to accept the null hypothesis and reject the alternative hypothesis. Hence, we can conclude that 40% of the female population in a certain neighborhood prefer brand S. Moving on to our next example. At a certain college, it is estimated that less than 20% are academic scholars. Is this a valid estimate if, in a random sample of 90 students, 9 are found to be academic scholars? Use 1% level of significance. So for this particular example, again, we follow the 4 steps in hypothesis testing, starting with the null and alternative hypothesis. So we state our null hypothesis as 20% of the population are academic scholars. In symbols, we write that as P equals 20%. And our alternative hypothesis would be less than 20% of the population are academic scholars, or P is less than 20%. So after you have stated your null and alternative hypothesis, we move on to step 2. We use 1% level of significance, and since we are trying to determine if less than 20% are academic scholars, then we use a left-tailed test. So at 1% level of significance, using a left-tailed test, we can see that our critical value lies at negative 2.33. So, if our computed Z value would be less than negative 2.33, then the decision must be to reject the null hypothesis. Next, we move on to step 3. So, in step 3, we're going to compute for the test statistic using the formula. So, let's identify our given values. So, X is equal to 9, P sub O is equal to 0.2, and Q sub O is equal to 0.8. Since 20% are academic, meaning 80% are non-academic scholars. And of course, our N, or our sample size, is 90. So plugging that into our formula, so we have 9 minus 90 times 0.2 all over the square root of 90 times 0.2 times 0.8 gives us a computed Z value of negative 2.37. So in step 4, since the computed Z value falls under the rejection region, and it is less than our critical value, which is negative 2.33, then we reject the null hypothesis and accept the alternative hypothesis. Hence, we can conclude that less than 20% of the population of students in a certain college are academic scholars. Now for our next example, we have the gas company claims that more than half of the houses in a certain city are using natural gas. Can the gas company prove its claim? If in a random sample of 200 houses, it is found that 111 houses use natural gas. So in this particular example, we are to use 10% level of significance. Again, we follow our 4 steps in hypothesis testing, starting with our null and alternative hypothesis. So our null hypothesis is that 50% of the houses in the city uses natural gas. So half, of course, is equivalent to 50%. So we write that in symbols as P is equal to 50%. While in our alternative hypothesis, we can say that more than 50% of the houses in the city uses natural gas, or P is greater than 50%. After stating our null and alternative hypothesis, we move on to step 2. In step 2, we identify our critical value using the type of test and the level of significance. So we are using 10% level of significance, and since we are determining if more than half of the houses are using natural gas, we use a right-tailed test. So using our standard normal probabilities table, we can see that our critical z-value is at 1.28. So if a computed z-value falls beyond or greater than 1.28, then the decision must be to reject the null hypothesis. Moving on to step 3. In step 3, again, we compute for the test statistic. So we identify our given values. X represents the number of houses that uses natural gas, therefore X is equal to 111. P sub O is the percentage that is assumed to be using natural gas, so that's 0.5. And the Q sub O is still 0.5. And N is equal to 200 since our random sample is composed of 200 houses. Substituting our given values to our formula, we have Z is equal to 111 minus 200 times 0.5 all over the square root of 200 times 0.5 times 0.5, giving us a computed Z value of 1.56. So since our computed z-value is greater than our critical z-value, which is 1.28, then we reject the null hypothesis and accept the alternative hypothesis. Hence, we can conclude that more than 50% of the houses in the city uses natural gas. So that's it for our lesson for today. I hope you have gotten something, and I'll see you all on our next video. Bye everyone.